मैं राकेश कुमार असवाल, गवर्नमेंट पॉलिटेक्निक कॉलेज, जयपुर. Students, yesterday I taught you about shear force and bending moment. These are force and bending moment are experienced on the beam, and we studied yesterday the support types of support of the beam and classification of the beams types: roller support, hinge support, fake support, and types of the beam: simply supported, cantilever, fixed, or continuous or propped beam. Today we will study, I will tell you about shear force diagram and bending moment diagram. So first case, we take a simply supported beam. There are types of beams. In number of types of beams, if we take a simply supported beam, and there are many types of loading: point load, UDL, uniformly distributed load, varying load, triangular load. About all these loads, we take one point load. Example: when simply supported beam, simply supported means the support, either both are roller or one hinge, one roller. Simply supported beam is subjected to point load. Here point load is W, capital W. Point load means that load which acts on a point of the beam. Here C is the point where W load is acting. So this is called point load because it is acting on a point. This is our problem. We have to draw this shear force diagram and bending moment diagram. One or two questions always asked in the examination every year. So this is most important chapter. This topic is most important. So we have to draw shear force diagram and bending moment diagram of a simply supported beam having or subjected to point load at C. L is the length between the supports. W is acting from one support. Distance is L by 2. So to solve such problems, first step is there that we should draw the sign convention. This is dotted line showing the section. This is showing section, and where we tick the section of the beam. Upward, section left side upward and right side downward, shear force will be taken as negative. Section left side clockwise and right side anti-clockwise will be taken as negative for bending moment. These are the sign convention. First we draw this sign convention. To solve this problem, first step is there. This we draw this sign convention. Then we have to calculate the reactions value RA and RB. Total load, whatever load, how much load on the beam is supported by two supports RA and RB, and the value of RA and RB have to be calculated first. These are called reactions at A, RA, reaction at B, RB. How can we get this reactions value, RA, RB? We take the moment either A or B. We know the moment at A because it is simply supported. The moment at A and moment at B is equal to 0. But if we take the moment, we get the equation of moment about either A or B. What will happen? We will see later on that we take the moment at support A, that is ME, moment at A. When we want to get the moment at A, section is at A, RB, right side. Then RB multiplied by the distance. Moment is force into perpendicular distance. So RB multiplied by distance. We are taking the moment about A. So distance is equal to L, capital L. Then RB into L. Direction. This direction is when we taking RB and taking moment about A, then it will go clockwise direction towards A. That's why section, where is section? Section at A. And moment, direction of moment, clockwise. Section, here is section. Moment is anti-clockwise from RB to A. The moment right side of section is anti-clockwise will be taken as negative. Section here, direction of moment anti-clockwise, and it is right side. It is again, it is also right side. Because we are taking the section at A, then it will be taken as negative. So here negative sign is this. Then W, there is no load between B and C, so we come to the point C, and this is W. W into this distance A to C, this is L by 2, because W is acting at a distance L by 2 from A. So W into L by 2. Direction, this will go in clockwise direction towards A. Go clockwise direction towards A. Then clockwise direction, right side of the section. Clockwise direction, right side of the section. That means it will be taken as positive, because anti-clockwise we are taking negative, so clockwise we will take positive. So W into L by 2, sign will be positive, and RA, we are taking this section at A and we are taking the moment at A. So RA, reaction is passing through point A, support A, so there is no perpendicular distance from RA and point A, so the distance is equal to 0. So that's why here the reaction RA will be cancelled and remaining RB is there. Then RB into L, we take it right side or left side. RB into L, this is equal to WL upon 2. By solving this problem, we get the value of RB. This is L cancel, this L by L cancel. RB is equal to W by 2. Since the total load on the beam is supported by two supports, RA and RB. So RA and plus RB, this is equal to total load. Here total load is W. Only one load is there. So this is equal to capital W. This is also follow this summation is equal to 0. Then RA plus putting the value of RB, W by 2, this is equal to W, then RA will be equal to W by 2. So we have got the value of RA, W by 2, RB, W by 2. The all forces are there on this beam, simply supported beam. So after getting the reactions value, we draw the shear force diagram.